Now we're ready to talk about z-scores. A z-score is a single number that tells you how unusual a piece of data is. If the piece of data is x, the mean is x bar, and the standard deviation is sigma, then the z-score is x minus x bar over sigma. Maybe you recognize x minus x bar from the formula for the standard deviation. That is the deviation alone. That is how far you are from the mean, and then if you divide by sigma, you're now not saying how far are you from the mean in absolute terms, but how far are you away from the mean in number of standard deviations. Let's do an example. Suppose the lengths of cobras are normally distributed with a mean of 11 feet and a standard deviation of 2 feet. What are the z-scores of snakes with lengths 12.5 feet and 3.7 feet? So you go out in your yard, you grab the first two cobras that you find. First one is 12.5 feet long. You say, hey, how unusual is that? Well, let's see. Here, the mean is 11 feet. The standard deviation is 2 feet. Now in the first case, we have x is 12.5. So the z-score corresponding with that is going to be 12.5 minus 11 divided by 2. Which is 1.5 over 2, which is 0.75. 0.75. What does that tell me? That tells me that it's a positive number. A positive number means you are more than average. That is a longer than average cobra. The fact that it's less than 1 kind of tells me it's still normal. That, 2/3 of the cobras out there are going to have a z-score between -1 and +1 because of the empirical rule. 68% of all the cobras are somewhere between z-score of -1, z-score of +1. The empirical rule for the 95% for the empirical rule says that 95% of all the cobras are somewhere between -2 z-score and +2 z-score. The cool thing is, if you want to talk about cobras, you have to talk about the 11 feet and the 2 feet. If you want to talk about z-scores, you're talking about anything that's normally distributed at once. Now, what about this 3.7 foot snake? Well, x is now 3.7 feet, and so the z-score corresponding with that is 3.7 minus 11 over 2, and I'm going to get out the calculator on this one. 3.7 minus 11 equals, divided by 2 is -3.65. -3.65. It's a negative number, which means it is less than average. Fine. It's -3. It's more than -3. This means this is a really unusual snake. Now, okay, maybe it's a baby cobra. If it's a baby cobra, okay, clearly baby cobras start off really, really small. Having a small cobra, not such a big deal. All babies are small. That's nothing to write home about. But if this is an adult cobra, if this is a full-grown, it's not growing anymore, 3.7 foot cobra, this is strange. Scientists might want to talk to you about this cobra that you found. This is like some sort of mutant runt, really weird cobra. Basically, what tiny little bit I've done in the world of science is a z-score above 2 or below -2 is interesting. If you are more than 2 standard deviations above the average height, that's pretty amazing. People are going to be constantly, every week, 2 or 3 people are going to look at you and say, gosh, you're tall. And if if you have a z-score of -2, that means you are 2 standard deviations below average. What is that saying? Remember how we said that everything up to, if this is average, and this is 1 standard deviation down, and this is 2 standard deviations down, here is x minus 2 standard deviations. If you have a z-score below -2, it means you are somewhere in here. And because it was 95% in there, and it's equal, you are one of the 2.5% smallest people in the world. people were going to say, you're short, as if you needed to know this information. This cobra that we found, that's not 2 standard deviations down. That we have to go down to 3 standard deviations. X minus 3 sigma. The number of cobras in there are, what was it? 0.15%. We're talking approximately 1.5 out of 1,000 cobras are that small. And we don't, and this isn't -3, this is even smaller. This is maybe one of the smallest cobras. I mean, this is probably 1 in 10,000 cobras. Next video, we'll talk about how to look up and find these percentages exactly, not just for 1 to -1, -2, but for z-scores like these.